What's up, guys? Welcome to 5.4. Last lesson we learned about the Pythagorean theorem, and so now we're moving into some Pythagorean extras, which means we're going to be learning some extra things to help you out with the Pythagorean theorem and to help you out with some more right triangles. Okay, let's jump into it. Okay, so the first thing we're going to look at is looking at this heading. It says we need to identify right triangles, meaning if you were given if you're given a triangle, or if you're given three measurements of a triangle, how would you identify or prove that that is a right triangle without knowing that degree measurement, okay? And the way we do that is we would use the Pythagorean theorem. Basically what this means is that if I plug in the two legs and square it and add it together, it's going to be equal to the hypotenuse squared. So that means if I plug everything in and it turns out to be true, then that means it is a right triangle. Okay, so let's go and look at this. So right now I have three side measurements. I have 9, 40, and I have 41. So automatically I know the hypotenuse is always your longest side length, opposite of your right angle, right? So that means the C value is going to be the biggest number, okay? Or one of the biggest numbers. So that means 41 is automatically your C value. And again, it doesn't matter the other two numbers if it's your A or B. So just for fun, I'm gonna call this A, I'm gonna call this B. So what I'm gonna do is I'm gonna take these three numbers, I'm gonna plug it into the equation, I'm gonna solve for it, and I'm gonna see if it all equals out in the end. So let's go ahead and look at it. So I have A squared is gonna be 9 squared, B squared is going to be 40 squared, and C squared is going to be 41 squared, okay? So let's go ahead and square all these and let's see what it turns out to be. So 9 squared, meaning 9 times 9 is going to be 81. 40 squared, which is 40 times 40, is going to turn out to be, it looks like 1600. And then 41 squared is going to turn out to be 1681. Okay, now 81 plus 1600 is going to give you 1681. And does 1681 equal 1681? I think it does. So what that means is that these three sides of a triangle are indeed a right triangle. Yes, it is a right triangle. It checks out. Boom. Okay, so that's how you identify right triangles. Okay. So the next thing we're going to look at is something called Pythagorean triples, okay? So we're going to basically, there is an unlimited amount of Pythagorean triples, meaning three numbers, whenever you put them into the Pythagorean theorem, it turns out to be a right triangle. Pythagorean triples means three numbers that are going to make a right triangle, but there are going to be two sets of Pythagorean triples that are going to reoccur kind of over and over throughout your math years. If you end up going to Algebra 2, if you end up going to Calculus, if you end up going to college math, these are well-known Pythagorean triples, okay? And these are things that it would help to memorize. So that would be a 3, 4, 5. So side length 3, side length 4, and 5, a 3, 4, 5 right triangle. And a 5, 12, and 13 right triangle. So these are base Pythagorean theorems that you guys can remember, okay? And just so you guys know, if you put through a multiple of these, meaning if you were to multiply the same number on each one of those, it still works out. So for instance, if I was to multiply each one of these numbers by 2, a 3, 4, 5 Pythagorean triple would still work out if I multiplied it by 2. So let's just go ahead and do that. So if I multiplied all of this by 2, times 2 would give me 6, 2 times 4 is going to give you 8, 2 times 5 is going to give you 10, okay? So now I'm going to put this through the Pythagorean theorem, right? 6 times 6 is going to give you 36, 8 times 8 is going to give you 64, 10 times 10 is 100, 36 plus 64 is going to give you 100. So they both check out. So that means if you're given three numbers, and you can see that I basically did a scale factor on each one of those and multiplied by a certain number to get there, I know that it would end up being a right triangle. So I know 6 divided by 2 would give me 3, 8 divided by 2 would give me 4, 10 divided by 2 would give me 5. So that's technically a 3, 4, 5 right triangle, but scaled up. okay? So that's how I would work by identifying something as a Pythagorean triple. The same thing would work as a 5, 12, and 13. So if I end up putting that through, it ended up working out to be a right triangle. So again, if I ended up multiplying these by 2, 2 times 5 is 10, 2 times 12 is 24, 2 times 13 is 26. Let's put it through Pythagorean theorem and see if it works. 10 times 10 is 100. 24 times 24 is going to give you 576. Then 26 times 26 is going to give you 676. Add these two together is going to give you 676 on both sides. So it still works, even though I scaled it up, okay? So again, it's a way that you guys can use these Pythagorean triples to try and simplify something in your brain to make it work out a lot easier, okay? So let's hop over and let's try and identify some right triangles. Okay, so now on example number 1 here, so we're going to try and prove that this is a right triangle or not, and I'm going to do that by using Pythagorean theorem. So a squared plus b squared is equal to c squared. So I know the c value is always going to be your hypotenuse. So the hypotenuse is always your longest side. So 5, 6, and 8, the longest side is going to be 8. And then a and b, it doesn't matter which one is which, so I'm just going to call that a and call that b. So a is 5, b is 6, c is 8. 5 times 5 is 25. 6 times 6 is 36. 8 times 2 is 64. So this would turn out to be 61. So does 61 equal 64? I do not think it does. So this is not a right triangle because it does not satisfy the Pythagorean theorem. So it is not a right triangle, okay? So now let's jump. So right now, if you look, remember we just now learned about something called Pythagorean triples. So let's go ahead and think back. I have a 3, 4, 5, and I have a 5, 12, 13, correct? Yep, okay. And so now what we're going to do is we're going to take that and kind of apply it here. Remember, I said I can multiply any number by those, and whatever that number comes out to be, it still can work out to be a Pythagorean triple. So let's go ahead and think. A 3, 4, 5. So the lowest number is going to be 9. Well, 3 times 3 is 9. The second number is 12. Well, 3 times 4 is 12, right? And then the biggest number here is 15. Well, 5, 3, 4, 5, 5 times 3 is 15. So that means I just took the 3, 4, 5 right triangle and I multiplied it times 3 to get these 3 sides. So without even doing the Pythagorean theorem, I know that this is just a scaled up version of the 3, 4, 5. So that means automatically it is a right triangle because it works out, okay? And I could even do the math if I wanted to just to show you. You could use Pythagorean theorem. So 9 squared plus 12 squared plus 15 squared. 9 squared is 81. 12 squared is 144. 15 times 15, give me 1 second, we'll get you an answer, is going to be 225. And then 144 plus 81 is indeed going to give you 225. So it works out. But again, the Pythagorean triple route would work a lot quicker on that instead of doing the Pythagorean theorem. So that makes this a right triangle, okay? All right, guys, look at example number 3. So do this for me. This shows that sometimes teacher error occurs. So what I need you to do is I need you to change this number 9. I need you to change it to 18. I need you to take this number 12. I need you to change it to 24. I need you to take this 15 and I need you to change it to 30, okay? So use your error right here, okay? So right now I need to prove if this is a right triangle, and I'm going to use Pythagorean theorem to do that. So right now I always know the longest side is going to be your C value, the other two is going to be your A and B. So let's go and plug it in. So A plus B plus or equals C squared, which is going to be 30 squared. Okay? So 18 times 18 is going to give you 324. 24 times 24 is going to give you 576. and then 30 times 30 should give you 900. And then 576 plus 324 is going to end up giving you 900. So 900 does equal 900. So that means this is indeed a right triangle because it satisfies the Pythagorean theorem. Check. Okay? All right, and lastly on example number 4 here, the thing you guys want to try and do in proving these or trying to figure these out if it's a right triangle, go ahead and think of those Pythagorean triples. So 3, 4, 5, the smallest number is 3. So the smallest number is 10 here. So a 3 can't go into 10. So we got 5, 12, and 13. So 5 is the lowest number, which can go into 10 2 times. 12 can go into 24 2 times. 13 can go into 26 2 times. So what this means is I took 5, I took 12, and I took 13, which is that Pythagorean triple, and I multiplied by 2 to get to this. 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. So that since this is just a scaled up version of the Pythagorean triple, that automatically proves that it is a right triangle by using the Pythagorean triple. It is a right triangle, okay? So ladies and gentlemen, take these methods. Sorry for the mishap and good luck with your skill check.